Do page 18, thank you. Yes. Top of page 18. Last week we multiplied monomials and divided monomials. If you weren't here, you have to watch the videos online and make sure you're caught up. And today we're going to learn something called the distributive property. And the distributive property works with regular numbers as well, but you have never had to use it before until now that we're dealing with algebra. So we've got some things. First of all, we've got a new command word here. Maybe my pen will start working. There it is. Expand. Okay? This is something that we sometimes put on our cheat sheet. Right? You get this, the question will just look like this, expand, and you're like, Mr. JR, what does expand mean? And I'm like, it's a quiz. I can't help you with what words mean on a quiz. You need to know what those words mean. That's part of learning and part of studying, right? And if you think you're going to forget what expand means, then maybe this part here in the blue box is something you add to your cheat sheet to help you remind you. Expand means to remove the brackets. Well, how do we do that? We do that with something called the distributive property. And the distributive property says that we multiply each term in the brackets by the term outside the brackets. Isaac, we're on page 18. What does that look like? Well, I often like to show the distributive property with a set of arrows, just like we did with the negative sign when we had brackets. Remember I drew the arrows on the negative side to say each of them changes sign as a way of remembering? I was kind of already doing the distributive property. The distributive property here says that 3 goes to each thing. And the answer, well, what do I get if I do 3 times x squared? Well, that's just smush it together, 3x squared. What would happen if I did 3 times a negative 5? Negative 15. And this is expanded. Do we have any like terms? Can I put the 3x squared and the 15 together? No. Because we can only add or subtract things that are like terms. So this is the idea. Yes, the back, but I have a different answer key. Okay. For the, you can do all the fronts first, and then I think this is the, yeah, here's the answer for the back. So we use the distributive property whenever we have an expand question, a set of brackets, and something outside the brackets. So if you have a negative outside here and you put on your math goggles, technically that negative has like a -1. And if we took a -1 and multiplied it through to each one, what would we get? Well, a -1 times a 3 would be -3. And a -1 times a -5?
-5.
Careful, what's negative times negative?
Oh, positive.
Positive 5. Which, having just a negative outside is the same as what we saw with subtracting. So just a negative outside, we've seen that before with the additive inverse, where if you were subtracting brackets, you would change all of the signs in the second one. Now we can think of it the same way as you're multiplying everything by a -1, and multiplying by that -1 would change the signs in the brackets. The 3x becomes -3x, the -5 becomes a positive 5. So we'll get a question like this. We're asked to expand We've got a number out in front. That -4 gets multiplied by each thing. So I like to show the arrows to remind myself that if I just use the distributive property and I distribute that -4 to each term, then I just have some practice with multiplying monomials that I need to do. I'm going to give you a head start. I want you to write down an answer. I'm going to put up the answer in a bit, and we're going to check to see how we did.
Yeah.
Ujú.
Entonces, el 5 con la X es un 5 negativo como.
Pero el 4 negativo va a ser multiplicado por el 5.
Entonces, sumando el que está.
Primero, multiplicar este va a ser 20 negativos, ¿lo ves? Ujú. Y aquí, 4 por 2 es 8, pero negativo por negativo es positivo, entonces suma. Okay, check. How did you do? Did you get first term? Negative 20x, because 4 times 5 is 20, but negative times positive is negative. Negative 4 times negative 2 will be a plus 8. Why? And negative 4 times a positive 6, negative 24. So you can use a calculator if you need, but you can see that it's going to take extra time. A lot of it is just your times table. We're practicing our times table. We're also practicing positive times negatives. So all of those things that we've learned earlier, they just come back and we practice them more and more. Notice that all the command words in here were expand. And expand means we had to use the distributive property. Our answer does not have brackets anymore. This next question says expand and simplify. The simplify part we've already learned means combine. In algebra, when we say simplify, we're going to need to combine all of our like terms. Expand means we need to get rid of the brackets.
Which one do you do first, though?
We'll expand first, because technically we still have bed mass happening here. And having a number outside in front of the brackets is multiplication. Normally in bed mass you do brackets first, but if you look inside this first bracket, do we have any like terms that we could actually put together? No. And the second bracket, are there any like terms you could put together? No. So you still do bed mass and say, I have to do my brackets first. But unless there's like terms in the bracket, there might be nothing we can do. But if you have a number outside of the bracket, we can distribute. So that 3 will get multiplied by each of those. And this -2 will get multiplied by each of those. So this question is going to take more than one step. Step 1, we're going to do the expand part where we use the distributive property. And you see that with the first set of brackets, you're going to have 3 things when you expand. In the second set, you have another 3 things. We're going to write out our next step is going to have 6 things. And we just have to take our time and make sure we don't make any mental math mistakes along the way. So the first one, 3 times 2. Multiply the numbers in front, so that would give you 6.
X plus.
And then we got x squared. And then 3 times a -3.
9.
Negative 9. Positive times a negative is negative. And 3 times 3 is 9, and you'd still have the x there. And then 3 times the 5 is going to be 15. If there's a subtract sign, when we distribute the 2, we actually distribute the 2 and the negative at the same time. So negative 2 times x squared minus 2x squared. Negative 2 times 2, negative 4x. And then negative 2 times negative 4,
Positive 8.
positive 8. So really what algebra does a lot is it's checking our mental math skills. Do we know our basic multiplication? Do we know negatives times positives, positives times negatives, negatives times negatives, and so on? Is it super easy to make a little mistake along the way? Yes. So often when you get your worksheets back, there's like lots of circles on numbers because you made little mistakes along the way. Now, like terms. I'm going to start by underlining this one in purple. Are there any terms that are alike with the 6x squared? Which one?
2x squared.
The minus 2x squared. Perfect. Next, I'm going to switch to green. I'm going to circle this minus 9x. Because I know you guys don't have a bunch of different colors, so you're going to have to use different shapes. Is there anything that is a like term with the minus 9x? The minus 4x. I'm going to circle that one as well. And then I'm going to use a square around the plus 15. Any like terms with plus 15?
Plus 8.
The plus 8. So I color coded those. I'm going to start with purple ones. If you had 6x squareds and you subtracted 2x squareds,
4x squared.
you would have 4x squareds. Just like if you had 6 apples and you subtracted 2 apples, you would have 4 apples. The thing doesn't change, it stays x squared, right? We just say I have 6 of them, I subtracted 2 of them, I'd have 4 of them left.
And plus 13.
Okay? Then the green ones. You have minus 9x's and you minus 4x's.
Wait, would it have to be positive?
Would it be positive 13x's or negative 13x's?
Positive.
Negative. You're not multiplying here. You're adding and subtracting. When we're like, the thing that I think you have to remember is when you're adding and subtracting, that's like our work on our number line. So here's our number line. We're starting here at minus 9. Right? That's my starting point. Minus 9x's. And I want to subtract 4 more of them. Subtracting is going this way. 4. 1, 2, 3, 4. What number would I end up if I went 4 backwards? I would be at not positive 13, because positive 13 is way over here, right?
Yeah.
That's going to be at negative 13x. So we find out in mathematics what is the easiest mistakes to make is when you start mixing up rules. Like we have rules for multiplying. A negative times a negative is positive. But that's not a rule for adding and subtracting, right? And if we're just memorizing rules and try to use them in different places, we're going to make mistakes. So we have to think back to what does it mean? Adding and subtracting. I always use the number line so you can see what it means, right? And it takes a lot of practice before you get to that point where you're like, oh, I get this now. I'm not going to make many mistakes anymore. But when we start off, oh, we make tons of mistakes because it's the first time that we're doing it. And then finally the blue ones. You're 15, you add 8. 23. So I've color coded. This was the purple ones. This was the green ones. And this was the blue ones. I'll put a circle around this. Sometimes it's really nice when you're all done, because it's a lot of work, to put a circle around your final answer. Question?
In a test,
Mhm.
do we have to like expand, simplify, and answer the question?
Yeah, so in this one, expand means the arrows part.
Yeah.
So I've expanded in my first thing here, but I have like terms. So simplify means if you have like terms, you should put them together.
Okay. Wait.
Yeah.
Any more
Yeah.
questions? Hold on, is that good?
Would we have to answer that question like?
Like this is the circle part is the answer.
Oh.
It has been expanded and it has been simplified.
La pregunta, entonces negativo, negativo, es como sumar, pero en negativo, entonces
Claro.
sería, por ejemplo, 9 por 11 es igual a 20 negativo. Igual con el
9
más,
negativo más 11 negativo es 20 negativo.
entonces es igual con el más.
So what Ruben was saying there is he made an observation that if you're subtracting or putting together two of them like we did in the green where if they're both negative, then you can just think about adding 9 plus 14 to get 13, but negative 9 and negative 4 will be negative 13.
That's what I.
That's what you do? That works out nice, doesn't it? So if they're the same sign, then you're going to add them together. If they're different signs, if one of them's positive and one of them's negative, then you're going to be subtracting them. Okay. So we use this distributive property whenever we're multiplying a monomial by a polynomial. And in this example, it says, can we find the area of this rectangle? Well, we know from our formulas that area is length times width. And I know that my length was 4x and my width was 3x plus 6. So I'm multiplying here a monomial times a binomial. And I can draw my aerials. If it said expand and simplify this, what would be my simplified expanded answer? Well, we've got this in our notes down here. We know that distribution says we draw our arrows and we do A times B, which would be AB, and A times C, which would be AC. So I'm going to draw my arrows here and multiply them. And my exponent laws are going to come back, which is what we were practicing last week. First set of arrows. What do you think I'm going to write first?
Okay.
Close. 4 times 3 is going to be 12. But what do I do with x times x?
2x.
Is it 2x? No.
Yes.
It's x with a little 2. 2x is different than x with the little 2. We would say this in English, we would say x squared. 2x is writing a 2 out in front. Yeah.
So if it would be like 5x times 3x, it would be like 15x.
Squared. Yeah. And then here, 4x times 6.
24.
Okay, I'll circle around that. Those aren't like terms because one has an x squared and one has an x. So we can't put them together. This would be our final answer. So now it combines our exponent laws and our new polynomial laws together. Okay, for each of these next ones, right? If you just copy down what I do, it doesn't really show you if you know what's happening. So for each of these, I'm going to get you to try first. And then we'll put up the answer and see how you did. We can even mark ourselves out of 2.
Do we also have to simplify?
If there is simplifying, yes, you'd also have to simplify. So this first one we're going to make out of 2 marks. 21.
I'll go back. I'm just.
Joe.
Sauce pencil.
Yeah, I'll put up the answer in a sec. Oh, my
Is that
battery.
right, Paul?
My battery's done here. I gotta switch. I switch mics. I don't like this one as much. Okay, are you ready? Turn the video back on.
Yeah, I'm ready.
Oh, I didn't turn it off. All right, I kept it going. Let's see how you did. I would give you a half mark for showing those arrows. Okay. Then 4x times x squared would give you 4x cubed. You would get a half a mark for that one. 4x times minus 5x negative 20x squared. Half a mark for that one. And 4x times negative 3 negative 12x. So you get a half a mark for each part. And if you did the arrows or showed that you knew that you were doing the arrows, you'd get that half a mark. And the signs have to be right. So give yourself a mark. Out of 2. Did you get 1.5 out of 2? 2 out of 2?
Oh, because there's 3 terms.
Wait,
So each one of these, basically, if you have a mistake with this one, you lose a half a mark. Mistake with this one, lose another half a mark. If all 3 of them are wrong, but kind of right, you'd get 0.5 out of 2.
That was fine.
so you would add the exponents.
You add the exponents, so if we put our math goggles on, right, this first one has a little exponent of 1, right? And you have 1x times another 2x's there, would be x times x times x, that would be x cubed. Okay, next one. Start on your own first. I'll put the answer up in a second. You did. Drawing arrows there. Drawing arrows here. Step 1. Negative 8a minus 14. You would get 1 mark for those ones. Step 2, distribute here. You would get 5a cubed plus 20a squared minus 10a. You would get 1 mark for the second one.
I get 1 wrong. I feel like this.
Then if we look here, this is a like term with this, but nothing else are like terms. So the final answer is to write, and I always start with the highest degree, so I'm going to write the 5a cubed first. Then I'm going to write the plus 20a squared. The minus 8a and the minus 10a are like terms. You would get negative 18a. And then finally the 14. The purple ones, when I put them together, oh, that's not purple. That got me the minus 18a. No more like terms. Circle that as my final answer. So putting the like terms together and getting the minus 18a was mark number 3. Yes.
Does it matter if you want to record like
That's right. The order doesn't matter. The preferred order is that you start with the highest degree and go down to the lowest. So this has a degree of 3, degree of 2, degree of 1. The constant term would be written last. Yes. Let's finish the notes first, okay? Let's see how you did on this one. First of all, did you draw the arrows?
Like that.
Next. When you multiply this ones, you'll get 2x cubed minus 10x squared plus 4x. You get 1 mark for that.
I got it.
Minus 6x plus 15.
Oh my god.
Step 1. We still have one more step, but I'm checking how we did on that one.
Yeah. I did mistake by anyways.
Yo, yeah, I get all of it right.
Okay.
You look back. You know what I'm gonna say? Make it like a whole minus b. Like, I remember what he knows. But it's fine.
Good, good, good.
We got it. This look at one.
All those are ready to go.
Okay, I'm good. Yeah, we got it.
Then next, do we have any like terms? Do we have anything with x cubed? Nope, that's only one. Anything else with x squared? Nope, but I have, those two are like terms. So my final step, 2x cubed minus 10x squared. What is a plus 4 minus 6? Negative 2x plus 15. We put a circle around this. This is the final answer.
Bro, it's like that's not actually not.
Everything combined, everything simplified.
Like it's not actually very. You know,
Yeah, it's basically yeah.
Okay.
There's a number outside of the brackets. This minus 8 is going to get distributed. What's a little bit weird on this one is the 2 out in front just stays a 2 out in front. And order of operations, distribution is like multiplying. The number one mistake here is people do this subtracting. They do 2 minus 8 first. But multiplying in order of operations happens before subtracting. So we have to do the arrows. We cannot do 2 minus 8 first. But it's so tempting to want to do that first. So now I'm going to get this times this is going to be minus 8 q squared. Negative times negative plus 24 q and negative 8 times 4 negative 32.
Let's go.
Okay. Now do we have any like terms? Yes. I've got this purple here and this purple here. Awesome. Thank you. And 2 minus 32 is going to be negative 8. I'll write it in order. 8q squared first plus the 24q. And then 2 minus 32 will give me negative 30. This I'll circle is the final answer. All right, try this next one. Example 6 is going to be our last example. We have the minus sign going to each one. So the 4 stays. We have 4 minus times this minus 4a minus times this minus 5b. We look, are any of them like terms?
No.
No. So we can put a circle around it. This is done.
Okay.
We can only keep going if we have like terms that we have to put together. So first we expand to get rid of the brackets. And sometimes when it's just a single number in front, it throws you off a little bit.
I was just gonna say that keeping the 4 will throw people off.
Okay, I'm noticing here, I'm gonna end the video here.